Okay, so here we are in video 6 for beginners. We have, in this one, we're going to focus on the data maps and the selectors together because together they make about as much as we have in some of these other ones. And they are very related. They are often used for masks or tools for generating textures. So often cases you can have mask related information coming off of an erosion node, or some of these other ones they'll have additional outputs. So something like breaker will have output for the breaks. Erosion has these different ones, the wear, the deposits, and flow, which you can output directly, and you can use, so here's I think this is deposits, or you could go from this into a curvature, and curvature will isolate information which you can then convert into color again. So this is the primary use for these kinds of masks. So we have these selectors, such as curvature. We have the data maps that are here. And data maps are very similar in certain ways to what you get in these erosion. In some cases there'll be things very similar to how they process it, so there'll be like a simulation aspect to it, or it may be something that's a little bit more overall elaborate, whereas things like selectors are a little bit more simple in terms of their rules. They do kind of like one thing, and that's about it, but it's an important thing. It's an important way of selecting or isolating certain information. So if I were to take this object right here and I want to isolate things based on angle, you can see how angle works. We have an azimuth. Azimuth basically is when we follow the sun going around, so it's going around here. And if I go ahead and change that, you see it will rotate around that space. And we have a min angle, which creates that separation there. A max angle, pulling that back and forth. And then of course we have a fall off, which gives us that gradient there. So we can have really sharp or not. So if you wanted to isolate things to just one side of a surface, you could then select that side of the surface and you could work from that. This is what it would look like on a more complex surface, but we'll come back to that when we get down into that area. We also have the ability to just directly paint masks. So where this is generated from information, we also have manual control. Manual control is very simple. You click the edit map, and then you paint where you want it to go. We can then go ahead and update that, and we can continue to add strokes and update them. We can add strokes, or we can erase strokes. There's also an undo and redo button, and there's of course a clear. We can control size, and overall strength. Again, clicking update, we see how that works. Let's go ahead and clear that, put that away. This can be combined with other things. You could apply a blur to soften it, or you could connect it to something else by combining the values or something like that in order to get more control in a specific area where most of it's been handled by this, but it needs some fine-tuning, where you can manually paint that stuff. In terms of some of these more involved ones, not all of them are super involved. If we take a look at this distribution, for example, this is essentially just a noisy node. It compresses the noise at the peak, and then as it goes down, the noise kind of expands outwards until it's no longer generated. So we have an overall occurrence control, which is the density of that noise pattern, but then there's also a density on top of that. So obviously occurrence is a lot more expensive versus density, but both work together, and then of course just changing the seed is just going to change the pattern that's there. Only slightly more elaborate would be the surfacer. In this case, instead of using simple sliders, we have a slider, but that slider doesn't do much for most of them. It's there for one of these options, but for the rest of them it really doesn't do a whole lot. What is more interesting is this drop down and choosing different methods of evaluating the surface for masking. In this particular case, it's a noise pattern again, very similar to what we saw in distribution, but it's applied based on angle information. If we were to go to the next surfacer, which is peaks, you'll see it's the same information, but it's non-noisy. One of the things that you should be aware of is the way that it evaluates these sort of max and min values. It's very similar to what we saw with things like the angle here, but it's radial, it's going all the way around, as well as something along the lines of slope, which we haven't looked at yet, and I believe we have over here. So slope looks at the angle kind of going upwards, and so it's sitting on the flat regions, and as I increase that, it'll creep its way up those slopes. So it's combining those kinds of pieces of information in order to isolate those sloped regions while ignoring the creases and the peaks. So it's working those midsections. To add additional breakup over a surface, there are certain angles. There's like this plus symbol that comes through that is being essentially ignored, and that just increases the breakup across the surface. So it may not look great on something smooth like this, but on something more detailed, it's very useful. Moving along in that same tool set, we also have isolation of those grooves. So this is just down in those crevices there. So that's the sliders. This one, I have to admit, I'm not entirely sure what its rules are based on, but it is another noise pattern. It's just larger blotches of noise, and often I notice that it does favor sort of edges in many cases, depending what the shape of the objects are in the interior. In this particular case, with this Berlin noise, it's covering it. In a lot of cases it really does kind of work its way in, but I'm not entirely sure of the rules that's applied to it. Next we have trace, and trace does use this strength. If I take the trace down in strength and apply that, you notice those lines here are crisper. It's dealing with the crevices, working its way up the slopes to the peaks. It's very similar in how curvature works. Curvature, you'll notice, is almost the same. Curvature will allow you to apply max and min values, which will add more contrast to these areas, and you can play with things like the fall off between these sort of extreme ranges. It's mainly just the peak. We can invert that so it's more selecting the crevices than anything else, and then we have different ways in which it evaluates that. So in terms of horizontal, you see the lines going this way are more evaluated. Vertical, you see the ones going this way are more evaluated. So this one is darker, but this one is brighter. And then if we do an average, it tries to get to both of them as best as it can. Creases are always really well isolated. Whereas for this one, as I increase it in strength, I'll actually apply that, you notice that it softens, so it's like it's applying a blur to that same kind of functionality. So you would say that this is essentially related, these three are essentially related to each other. With the next one here, wind streaks, you can see what that kind of looks like. Just to make it a bit more obvious, we'll switch colors so that you can see the different regions. And what you'll notice is similar to what you get with the surfacer. We have the crevices selected here, but it's been expanded, something that you could do with something like aperture. You could go ahead and expand those regions. And these effects is basically just height map information with these streaks. It's like breaking up this gradient into chunks in the way that you see here. So I've done a quick example of what that would kind of look like. I've got a single clutter node, and I've got another one based on height, which what it's doing is just taking this gradient and applying it in height information. I've gone ahead and used that surfacer node, which provides that range, and then with aperture expanding it. And when I mix it together, again you see that area that's been masked out and these lines being produced. So that is in essence is what it's doing to this, and it's all been built into a single function. Moving along, we have soil, another example of soil. When you work with these, what it's looking for is these indentations in the surface. It's looking for these pockets in which it can rest. This is where soil can kind of collect and kind of grow. If I were to take this one and look at it in blue here, you can kind of see a little bit easier how it's settling into any crevice on any angle as long as it does an indentation. Another thing that we can do with these is using things like a height node that we'll play with a little bit later. We can play with the range, and it would do something kind of like this, where you could sharpen and isolate certain regions. If I were to invert this, it would just be the really ragged raised edges, which I could do things to sharpen them or add noise to them or soften them. Anything that I wanted to do, and then it would ignore these other regions, so I can use it to mask that out, not just for color purposes, but for, you know, affecting the surface. If I go ahead and take this and tell it to be graded, we have a better gradient across to avoiding these sharp edges and filling in these crevices. And if I do the same thing that I just did in this particular case, you see it more clearly isolates just the ridge. So if you really wanted to get your hands on those ridges, you would use a graded version of that same node, and you could isolate those ridges fairly nicely. So a lot of these things will have a distinctive purpose based on their name. You kind of know what they're used for, but they can be used in any way that you have imagination for. How do you want to use it, and then just kind of go for it. Growth. Growth looks for some of those crevices, but it also follows the idea of sort of the flow that you would have from erosion. If I look at the flow that erosion works with, so this is actually the deposits. So those are those areas in there. You can see some of that coming across. But also if I went to flow, and you can see how these things are kind of dripping and falling down and tracing their path through there, sort of like particles just falling across the surface and tracing their way as they go down. So elements like that are applied to growth. If I did something like fit rivers, you will see it much more obviously. So you can see how we have these sort of traced lines going down through the surface. We also have grooves, or groves rather, not grooves, groves. And that one's much more like the deposits. Again, right? So you can see it's similar to that, just sort of the flow going down and filling that area. Just a little bit smoother. If I did that, yeah. So it's these sort of piles through here. What is different with this is that it does have a scattering and sort of noise factor to it. It does these little blotches all over the place as well. The primary use for this can be either texture or distribution of elements. If you wanted, you know, little rocks down here, and as the colors get brighter, you add maybe some larger rocks. You would have these little piles of those, or they could be patches of greenery, grass, high grass. Happens in the brighter areas, and lower grass happens in the lower areas, mossy patches, etc., etc. So there's all sorts of ways that you can utilize it for distribution in tools like, you know, Maya's Mesh, or in Unreal's scattering tools, Houdini, etc. Moving along, if we go back to the regular, and we did something like increasing duration, what you'll notice is this will take a little bit longer to calculate, and it will essentially get a little bit brighter, a little bit fuller. If I go ahead and take that back down to normal just by right clicking and then clicking the home button, I'll bring it back down here, I could easily do a very similar thing just by applying a gamma node and raising the value. But I'll save a few cycles in that particular case. So it's not exactly the same thing, but it is similar enough that if all I really wanted was to sort of expand the range that it was covering, that's an easy way to do that. And you could do that with gamma, or you could try like a bias gain or auto levels or whatnot to play with. Each one will handle it in a slightly different way, and you can look at those in the other video. Furthermore, with this, we have the slope, which should be relatively straightforward. It's sort of affecting to a certain degree the angle in which it can grow, but it does provide sort of like a scattering effect. As I increase it up, you see that it's not now growing everywhere, it's kind of growing in these lower sort of regions. Spread essentially alters the fall off. So as I adjust that with this lower value, you'll see that it will start to creep up the mountain and expand. So it gets a little bit wider, and that fall off, and I'm not sure where the fall off begins and ends. This is again a combination of different behaviors applied with the sort of stamping of this scattered noise. Increasing things like wild growth will increase the scatter of these generation areas, so it will spread out much further, creating a slightly more chaotic look, more patchwork kind of look, which is pretty cool. And again, for the purposes of distribution or applying, you know, textures in certain areas, it's very useful. This is one of my favorites. At higher resolutions, you will start to notice things like growth will produce a visible sort of spiderweb pattern. And I think that has to do with the way that sort of the simulation of this works. I think it's sort of like particles on the system kind of spreading outwards, and you'll have to tweak the values in order to make those feel a little bit more natural. Some other things that you have related to this are the graininess, so how noisy it is, and then the cragginess, which is sort of like a displacement applied to these. And so you can change these values to break up those patterns a bit more. Slope, as we already briefly looked at, fairly useful for creating the simulation of snow, and this is what it's been used for in a lot of different scenarios. So the settlement of sand or snow, anything that has to sit on a specific angle, slope is typically being used for. So you have that fall off and your max and min angles. So just sharpen that back up again. And then you have min, which is you have a minimum angle, so it only hangs out in one specific region. So it only hangs on the walls as opposed to the flat areas. So you can go either way with it. Moving along. We have flow, and as flow starts off, there's a lot of it sort of scattered all through these different areas. The spread on that is quite high. As we increase the rain cycles, though, it becomes a bit more focused, and so you can work within ranges and get a little bit lower. You see there'd be, again, a lot more of them, so the lower that number I go, the more spread and broken up that is. The higher the number I go, and the more concentrated these lines will be, so they kind of merge together. It also pulls away from that center, sort of fading off, creating sort of a gradient. We also have this constant rainfall, which determines, to a certain degree, kind of like the repetitive factor to it. So in the smaller quantities, you can see here it doesn't fill in that central area that repeated action would do. So you just kind of get the first sort of iteration of those. The real low level, you won't see much difference between the two of them. You have to add a few additional cycles and then you'll be able to see it. So this is of course a simulation of these things kind of falling down and flowing through these different creviced areas, tracing its way. And so you see the veiny pattern that's produced, very similar again to what you might see from one of the erosion nodes. Related to that would be our velocity node. The velocity node has a little bit more information and there's more to control. So we have duration, which again, just like anything else, takes longer for it to produce. And similar to what happens with flow, it tends to become less intense near the peaks and more concentrated in the sort of central core. It's almost like it's blurring perhaps the dark part of the mask. Setting that back, again we'll speed it back up so it'll happen a little bit faster. We have the amount of rain, so it's just the sort of like the intensity to the actual individual strands here. So more equals more overall kind of coverage of those things. We have a reach low and a reach high. Reach high will be a little bit more obvious if we do this. It's just a height cutoff. So you can see it's just the controlling the peaks. And the other one, which I don't really use, but it's here, you can play with this velocity high. And so because this is called velocity, the idea is that we have this perhaps this sort of starting velocity, and as it goes down it increases in speed, rolling down to its final destination and then coming to a stop. It will cut off the high velocity values. So if I do this, it actually doesn't even record that information. It goes immediately to black. So this creates sort of a weird, sort of sharp edged angle, and there may be a legitimate use for this. I haven't come up with one yet. I haven't had a reason to use this, but it's there if you have an idea. The next feature is angle, and if you look at this, you'll notice that there's a darker region and then lighter regions, and it's very similar to what we see here. I have, you know, a fall off, just expand that outwards and just sort of soften it. We have a max and min value. So you should see sort of that fall off in there. And then we have that azimuth. So I take it and roll it around, it comes from different angles. That's essentially what this angle's meant to do, that the flow will happen more intensely on one side and less intensely on the other side. So what else we have? Height. It's a very straightforward one. If we look at the height node, we have a max and min value. This isn't a very tall mountain, so really have to work in kind of this one range. And so you can cut off the peaks, cut off the base, work in the middle, or do all that, and then you have your fall off for overall sharpness of those zones. So you can have it really sharp or have a little bit of a blur to that. So once again, we have our angle, which is an overall angle completely all the way around. We looked at that first. We have our curvature, which deals with the peaks and the crevices. We have the height information, which we see here. We have the mask, which we can hand paint. We have the slope, which is mimicking the idea of snow more frequently. That's the most common usage for it. But there's, you know, if you want to select just the walls to do certain things to them, be it coloring or texturing, or erosion or blurring, or adding, you know, breakup with something like stratify to just those regions, you can do that. You can apply it to those. We have velocity and flow, which are both sort of rainfall kind of simulations, each with their own different controls. We have growth and soil, which pay attention to the crevices, but growth also has things similar to velocity in that it considers the flow of soil and rainwater and those kinds of things and how they work into grooves. We have the distribution node, which is changing the intensity from the top to the bottom, just delivering noise. And we have the surfacer, which has those multiple different methods that it calculates on. So that's it for these particular nodes. Hopefully you've gotten something from this. You get a better idea of how they operate. In other videos we'll talk about more specific uses for them, but again, as in the previous videos, I recommend that you go ahead and play with them and experiment. Have lots of happy accidents and see what you can create. See you in the next one.